Welcome to this practice set on one-step equations. Please give this video a thumbs up if you find it helpful, and let me know if you have any questions about the content of this video. Pause the video to work these problems on your own, then come back to check your work. Okay, so let's go ahead and get started with these one-step equations. And we are at this level where you're first learning how to do equations, focusing on the process. So even if you can give me the answers to these equations without doing any work and you think, well, that's like silly, I shouldn't have to write stuff down, remember that equations do get progressively more complex. And in order to be prepared for those more complex equations, we need to ground the process and the reasoning at the earliest level. So that first equation, we have 7 plus some number t equals 20. And you might know just by looking at it that t has to be equal to 13 because 7 plus 13 would give you 20. But again, this is about the process. So what we want to do is get the t by itself. And looking at it, we have this 7 over here that we don't want there. We want to remove the 7 so that we have just t equals some number. So we use our properties and we use some of the key ideas that were covered in the video. And what we'll do is we'll add -7 to that left side. And so we'll have 7 plus -7 plus t. Now, in order to keep the equation balanced, we also have to add a -7 to the other side, and that keeps that equation balanced. Whatever you do to the left side of the equation, so if we add a -7 to the left, we must also add a -7 to the right. And you always want to keep your eyes fixed on that equal sign, working top to bottom. And then we use this fact that any number plus its opposite is equal to 0. So 7 plus -7 is 0. And over here on the right, 20 plus -7 will give us the 13, and 0 plus t is equal to t. So 0 plus anything will give you that anything and leave it unchanged. You may also show the work this way. Okay, so your teacher might show it this way, where you have a +7 here, where you would show it by subtracting 7 from both sides. 7 minus 7 is the 0. 20 minus 7 is the 13, and you can get there showing the work that way. Both ways are completely okay for showing your work. But again, when you're first doing this, I know I'm sounding like a broken record here, if you know what a broken record is, but I can't emphasize this enough based off of what I see in my own classes that goes wrong at higher levels. Second one, m plus 10 is equal to 9. So once again, we want to get the m by itself, and we have this plus 10 here that we don't want. And so we will get rid of that plus 10 by adding its opposite. We're going to add a -10. If I add a -10 to the left, I must also add a -10 to the right, and any number plus its opposite is 0. On the right-hand side, 9 plus -10 is -1, and m plus 0 is m. So m is equal to -1. The other way you might see this worked out is you might see, instead of adding a -10, subtracting 10, and that will often be written below. And then we would have 10 minus 10 is 0. 9 minus 10 is the -1, and you can get the m is equal to -1, showing the work that way. Last one here, n minus 14 is equal to 10, and I'm going to do a quick rewrite on that and say n plus -14 is equal to 10, and that allows me to leverage adding the opposite. So I'm going to add the opposite of -14, which is +14. And if I add +14 to the left, I must add 14 to the right. -14 plus 14 is 0, and 10 plus 14 is 24, giving me n is equal to 24. If you show that using addition going down, you would say this is minus 14. How would I undo subtracting 14? Well, I would undo that by adding 14. And again, you want to show that on both sides. Remember, there should be an equal sign all the time in between your steps. Negative 14 plus 14 is 0. And then you have the 24 over there, and n plus 0 is just n. So both types of work, I would say the work that I'm showing second is the more common way now to show it. I do think it misses a little bit of the adding of the opposite and why things are equal to 0, but I would recommend doing whatever you're doing in your class or whatever your teacher recommends. All right, number 4. So we have negative 3 plus x is equal to 5, and we want to get that x by itself, so we have that negative 3, and I can get rid of that negative 3 by adding the opposite of negative 3, which is positive 3. And if I add a positive 3 to the left, I must add a positive 3 to the right. Negative 3 plus 3 is 0. 5 plus 3 is 8, and 0 plus x is just x, leaving me with x is equal to 8. Using that top-down notation, you might add the 3 underneath, and here you would see negative 3 plus 3 is 0, and 0 plus x is just equal to x. So comparable amounts of work there. Let's take a look at the next one. We have 5 times t, and it is important to remember that that is multiplication there. So this is multiplication right in between the 5 and the t. I have a lot of my students that if I ask them what is the operation happening there, they actually cannot give me the right answer. So that is multiplication. We can undo that by multiplying by the reciprocal. So the reciprocal would be 1/5. And if I multiply the left by 1/5, I must also multiply the right by 1/5. 1/5 times 5 is equal to 1. And 25 times 1/5 is equal to 5. Or you could think 1/5 of 25. Kind of read it that way, 1/5 of 25. And 1 times t is just t. The more common way of writing that problem would be to say, this is multiplication. How do I undo multiplication? Well, I undo it with division. 5 divided by 5 is 1. 25 divided by 5 is 5. And there's your work that way. I actually prefer it the way that I did it on the right. I think that's vastly easier to write down, and it's not difficult to process. It's a little bit trickier with that reciprocal piece there, but both ways do work. And last one here, we have x divided by -2 is equal to 15. And for this one, doing it out using the definition, we would take that division and we'd write it as multiplying by the reciprocal. So this would be like x times 1 over -2. And then I'll actually save myself a little bit of space here. To undo that, we would multiply by the reciprocal, which is -2 over 1. And we just got to make sure we do the same thing to both sides. Right here, a number times its reciprocal is equal to 1. And over here on the right, 15 times -2 gives me -30. So x is -30. The more common way of doing that and showing the work would be to reason it this way. This here is division, and we undo division with multiplication. So we multiply both sides by -2, and then -2 divided by -2, like right here, you've got those canceling out to the 1, and then you have the -30 over there. Okay, so x is -30. Next one gets into a couple of just, I don't know, different variations that you could see on these one-step equations. So for number 7, we have the variable on the right, and that can trip up a lot of people. So if it really, really bothers you, you can use what's called the symmetric property, which is that which says that equality is symmetric. Now, not every relationship is symmetric, but equality is. So if you ever have something on the left or on the right and you don't like it on that side and it's an equal sign, you are free to just change the sign so that you're more comfortable with it. So one of the things you can do with this one is you can just switch the order and say t plus 5 is equal to 3. That's totally fine. Or you can just go ahead and solve it with the variable on the right. This is adding. So to get rid of the adding, we will add the opposite. We'll add the negative 5, which means I also have to add negative 5 on the left. So we have 5 plus negative 5 there, which is 0. Negative 5 plus 3 on the left is negative 2. And so negative 2 is equal to t. And some people will leave it like that. Some people will switch it around to say t is equal to negative 2 when they're done. I got kind of a dot there. There we go. Negative 2, or you can do it this way. Now, if you rewrite it this way, or if you, I guess you could do it if you leave it the other way as well, you could say, well, how do we undo addition? We undo addition with subtraction. Therefore, I will subtract 5 from both sides. 5 minus 5 is 0, and 3 minus 5 is negative 2. Therefore, t is equal to negative 2. Next one, negative 4 is, this is number 8. Negative 4 is equal to negative 2m. And I'm going to go ahead and do this the way that I think the vast majority of people do it. Because I think when we change this to multiplication, well, I guess we can do this one by multiplication by the reciprocal anyway, because it's multiplication here. But if I want to undo that multiplication, I would undo it with division. And so I would divide both sides by negative 2. And just like a quick note that if you have stuff and you divide by negative 2, that is the same thing as multiplying by negative 1/2. So it's the same as multiplying by the reciprocal. So those two things are the same operation. On the left-hand side, negative 4 divided by negative 2 is positive 2. And then negative 2 divided by negative 2 is 1. And so we end up with m is equal to 2. Last but not least is problem number 9, which has all these fun fractions in it, but we're not going to get freaked out by it. So if you've got something being multiplied here, we need that to be a 1. So we need it to be 1x. The way to get a 1x is to multiply by the reciprocal. So the reciprocal of 4/5 is 5/4, and whatever I do to one side, I do to the other side. Any number times its reciprocal is equal to 1. And then over here on the right, I have 2 times 5 is 10, and 3 times 4 is 12. 1 times x is just x, and then if you need to simplify that fraction, it simplifies to 5/6. And so there we have that last one. And last but not least, we have this lovely problem. You have a balance of $150 in your checkbook. So this requires that you know a little bit of the vocabulary. So let's kind of go back and pick this up. If the balance is like how much is there, okay, like how much money is there. So you have a balance of $150 in your checkbook. So you open up your checkbook and you look to see how much money do I have? How much money is there? And your checkbook says $150. Now the bank says you have a balance of $120. Now that means that how much money you say you have in your checking account is different from how much money the bank says you have in your checking account. And the bank says you only have $120. You realize that you forgot to record an automatic withdrawal. So when you get to the point where you have a checking account, you can write checks or pay bills online through that checking account, but you can also set up certain things to come automatically out of your checking account. So somebody comes in, it's a little unnerving, I think it is, but right now I have a certain amount of money that's coming out every month for a trip that I want to go on. And so they just go into my checking account and I get a little notification saying, hey, this money has been taken out. So what is happening here is you've got some kind of automatic withdrawal. You're paying off something and they're coming in and they're taking it out and you forgot to write it down. The bank has it written down, but you don't have it written down. Which equation models this situation where M is the amount of the automatic withdrawal? So this is the amount you have. So you have this much. This is the unknown withdrawal. And this is what the bank says you have. Okay, so if you take the amount that you have and you subtract from it the amount of the withdrawal, then it should match what the bank has. And that process where you go through and you check everything out and you make sure that the number you have and what the bank has is the same number, that's called balancing your checkbook. And it's something that I was taught to do about once a month, every so often. And I still do it because you want to make sure that you're not forgetting things and that you think you have a certain amount and the bank says something different. Now, this one would be if you had the amount of the withdrawal and subtracted from that your balance, what you think you have, that would somehow give you the bank balance, and that should not work. So it's possible that you did not get this one correct. So the one that works, the one that is the answer is A. Okay. And it's possible you might not get that one correct because of knowing the vocabulary in the situation. And I want you to pay attention to that sometimes you can get problems wrong. And it doesn't mean that you don't know the math. It could just be the vocabulary and understanding the situation. And when that happens, it's not even really if it happens, but when it happens, that's the question that you need to go to your teacher with and just say, I don't know what a balance in the checkbook is in order to make sense of this problem. And those are perfectly good questions to ask. So as always, give this video a thumbs up if it helped you work through these one-step equations. Leave me a comment, let me know what you think or what you'd like to see, or if you have any questions. I'll see you in the next one.